Hi, and welcome to a brand new video. Today we'll be tackling the screen where you're given just an array nums and you need to find all possible subsets. This might seem pretty complex, especially because you're not allowed to put duplicates, but we can solve it with our tool recursion. So all I'm going to do here is declare two class variables. I'm going to declare a private list integer of ands, which is what we're going to be returning. And I'm also going to set private, and I'm just going to make these all static so that we don't have to create an instance static. And I'm also going to store this nums publicly because we're not changing it. And all we need to do is say this.nums is equal to nums, and also create a new create something new for ants. So looks like there's an error, can't use this in static context. Maybe we have to remove this for that. Okay, cool, I'll just remove that and then create an instance of main. So main x equal new, oh, sorry, subset 2 x is equal to, oh, I already declared that, so I guess subset is equal to new subset 2. Then we can just do subset dot subsets with dupe. So we can also set this dot ands to be new array list. And this will just allow us to access these two variables from any other method we have without having to pass in parameters, which will save a lot of space and ultimately time as well. Next, I'm just going to create a recursive function. It's not going to return anything, and it's going to take in two parameters. It's first going to take in a list of integers. So what we're going to do is we're going to use recursion to basically iterate through the array. So we're going to have an index, and then we're going to call recursion to include the element and then go to the next one or not include it. So technically at every single integer there's two branches basically, and that will generate all the possible subsets. So that's why we're going to create a list integer of the currently running set of integers, and we're also going to have the current index that we're at. Now there's two possible things we could do with this, or once we get the index. The index could be equal to, could be equal to nums.length. And when that happens, that means we're done. So all we need to do is basically ands.add array. And I'll come back to how we need to improve this in a minute. But that's basically the basic idea. And then otherwise, what we're going to do is we're going to first clone array. So because these are objects, so they'll affect the same instance if we don't clone it. And say new array list. And inside here, I'm just going to put R. And this will clone the array. And then in clone, we can add nums of index. And then we're going to call two versions of recursive. We're first going to call clone with an index of +1, or we're going to call recursive of array with index +1. So clone has the array, it has the new integer, and this does not. So for each number, we're deciding whether or not it's going to go into the array or not. So this is basically the bare bones of this method. So what we would do for this solution is we would first just create a blank list and then call recursive. And then we return ands. But here's the thing, we can't have duplicates, and right now it's adding all of it, which means that there are still duplicates. And in order to fix this, we're going to create a new method. And this is just going to check whether the list passed in is already contained inside ands. So all we need to do is say that for list integer x in ands, if x dot equals array, return true, otherwise return false. So that right over here, we can say if contains array. So if it doesn't contain it already, then add it. There's just one very, very minor thing that we're forgetting. Sometimes 144 is the same as 414. And right now it considers that as two different instances. So there's a really easy fix to this. All we need to do is right here do collections.sort of array. And what that will do is that it will sort it before putting it in this ands here, and it'll also sort it before comparing it. So we're always comparing two sorted collections. So therefore, there won't be any duplicate instances now. So let's run our program. I just pulled the example from the spreadsheet. So let's compare. So we first have this one, we have this one, we have this one, we have this one, we have this one, and then we have this one. So therefore, we're able to solve the problem successfully. So I hope this video was helpful, and see you in the next video.